Assalamualaikum and hello everyone. My name is Muhammad Adil Azim bin Azhar and my matrix number is E25P3635. Today I would like to talk about geological mapping activity. This presentation details our field task focused on identifying and examining 4 geological outcrops around the Jelly campus as part of our basic geological mapping activity. Our primary aim was to observe and document key physical properties such as color, hardness, and weathering types to understand how different rocks react to their environment over time. Location and site. The specific observation we are highlighting today took place at Kampung Kembang Lama, Ailanas on April 13, 2026. Using our field instrument, we record the coordinate at north latitude as we can see in the picture and east longitude as you can see in the picture. As shown in the compass data from the picture, the slope faces northeast direction, offering a clear profile for mapping. Physical properties, scale and hardness. To strengthen our fieldwork skill in detail observation, we use a human scale to estimate the outcrop height at approximately 2 meters. We noted that the material is soft to moderately formed. This identified that the original rock has undergone significant transformation, turning into residual soil, a critical observation for our geological mapping data. Weathering process, and one of our main goals was documenting weathering. This outcrop show intense chemical weathering, driven by high temperature and heavy rainfall. Structurally, it is a massive with no distinct layering. The reddish brown in the material indicate the presence of iron oxide, a direct result of chemical breakdown of the parent rock. Lithology and rock fragment. As we see in the sketch, the outcrop isn't just soil, it contains light colored rock fragment or clasts. These are remnants of the parent rock. Identifying these evident pieces help us interpret the weathering grade, transitioning from grade 6 resident soil to more intact grade 5 or 4 weathered rock deeper inside.
Assalamualaikum and good morning everyone. Today I would like to present our outcrop observation study conducted near Block C, Asrama IBS PMK Jeli, close to Kampung Kembang Lama, Ailanas. First observation was conducted on 20 April 2026 at 4:48 p.m. Based on our field observation, the outcrop has an estimated height of about 2 meters and a width of around 4 meters. From the sketch and photograph, we can see that the outcrop is located in a forested area and surrounded by vegetation. The rock surface is partly exposed and some areas are covered by soil, leaf litter and plant roots. The rock appear grey to greenish grey in color. It is hard and compact, indicating that the rock has a massive structure. No obvious layering can be clearly observed on the outcrop surface. In terms of weathering, the outcrop shows moderated weathering due to long exposure to water, temperature change, plant roots, and atmospheric condition. Biological weathering can also be observed because roots and vegetation are growing around the rock surface. Overall, these outcrop provide useful information about the weathering process and surface geological condition in the study area. In terms of weathering, the outcrop shows moderated weathering due to long exposure to water, temperature change, plant roots, and atmospheric condition. Biological weathering can also be observed because roots and vegetation are growing around the rock surface. Overall, these outcrop provide useful information about the weathering process and surface geological condition in the study area. For this second outcrop observation, the study was conducted near Ailanas, Kelantan on 20 April 2026 at 4:32 p.m. Based on our observation, the outcrop is located along a roadside slope and is surrounded by dense vegetation such as fern and small plants. The outcrop mainly consists of highly weathered soil and rock material. The surface color range from brown to reddish brown, which indicates a strong weathering process. Most part of the outcrop are covered by vegetation and loose soil materials. In terms of hardness, the material appears soft to moderately hard because the rock has undergone intense weathering over time. No clear rocks layering can be observed due to the heavy weathering and soil cover. Several weathering processes can be identified at this outcrop. Physical weathering occurs due to erosion and temperature change. while chemical weathering happens through prolonged exposure to rainwater and oxidation. Biological weathering is also present because plants, roots, and vegetation grow around the slope area. Overall, this outcrop shows evidence of intense weathering and slope exposure in a tropical environment.
Hello, my name is Siti Nur Azwani binti Jasni and my metric number is E25A3702. Third location is near the library. First, the date and time of the fieldwork was on 20 April 2023 at 4:29 p.m. The location of the outcrop is beside the library on the right side area of the campus. The GPS coordinate record for this location is 230 degree southwest. The location was also pinged using Google Image or Google Maps. For the outcrop description, the outcrop has an estimate height of about 3.5 meter and a width of about 9 meter. In terms of the rock description, the rock features a distinct black and grey color palette with a texture that is generally very hard. Although some areas are softer due to active weathering process, the harder sections are mainly affected by physical weathering such as thermal expansion, while the softer portions are influenced by chemical weathering, specifically oxidation and hydrolysis. This process gradually breaks down the solid dark rock and eventually transform it into the soft reddish-brown earthy material observed in the surrounding area. From this fieldwork, we gain a better understanding of basic geological mapping and rock observation technique in the fields. Discussion. Based on the observation, the outcrop around UMK Jeli show different characteristics in color, hardness, and weathering process. Most of the outcrop experience chemical weathering due to the hot and humid tropical climate. Some outcrop were soft and reddish brown because the rock shape weathered into residual soil, while others were harder and less weathered. Vegetation such as ferns and small plants also grew on several outcrops because the soil contained enough nutrients and moisturized. This fieldwork helps students understand how rocks change over time and improve their geological observation skill. Conclusion. The geological mapping activity successfully identified several outcrops around the UMK Jeli campus. The study showed that weathering process strongly affect the condition of rock and soil in the area. Students were able to observe the physical properties of the outcrop and gain practical experience in geological fieldwork, including observation, sketching, and recording field data. Next, we move to the first question. First, explain the innovation regarding the basic geological mapping on the campus area for the geoscience student to access the outcrop. Innovation in basic geological mapping on campus for geoscience students is to enhance geoscience education, and innovative approach has been implemented to make geological mapping around the campus more interactive, accessible, and practical for students. This initiative focuses on enabling hands-on learning through direct observation of natural outcrop, soil profile, and minor structural features within the campus area. One of the key innovations is the digitally integrated campus geological map developed using GIS and drone survey. This map identifies and documents rock outcrop, soil profile, and minor fault across the campus. It is accessible through online platform and mobile application, allowing students to conduct pre-field preparation and virtually navigate outcrop location before actual fieldwork. In addition, field access pathway and signage system have been introduced to ensure safe and controlled access to geological sites while minimizing environmental impact. At each outcrop location, QR code information board provide immediate access to geological description, stratigraphic details, and previous field observation, enhancing self-directed learning in the field. Furthermore, selected outcrops are supported with hands-on learning kit, which include tools such as hand lens, rock and mineral sample, and field notebook to encourage direct observation and interpretation. Some sites are also enhanced with augmented reality AR feature, allowing students to visualize subsurface structure and geological formation in real time. Finally, collaborative student projects are updated and integrated through a centralized online database where students upload field observation, sketch, and interpretation. This promotes continuous data sharing, peer learning, and student involvement in ongoing geological research on campus. Overall, this innovation transformed the campus into a living laboratory that enhances accessibility, safety, and engagement while strengthening practical geological mapping skill among students. The second question is explain the practical approach from the enhanced student-centered learning and active participation during the fieldwork embedded together with the latest technology tools to enhance the experience for student learning in the field. Innovative approach to student-centered fieldwork practical approach. Fieldwork is designed to shift learning from passive instruction to active. Student-centered engagement by integrating inquiries, hands-on participation, and technology to enhance real field experience. First, in student-centered learning, students actively shape their fieldwork by formulating their own question or hypothesis before going to the site, selecting suitable method and location for data collection, and discussing their plans with peers. During fieldwork, they make decisions on how to investigate features such as rock outcrops, soil profile, or ecological patterns based on their own observation. Second, active participation in fieldwork is implemented through hands-on activity where students directly collect data, use field instruments, measure and record observation, and work in teams to solve real field problems. They also make real-time decisions in the field, such as adjusting mapping strategy when encountering new geological structure or unexpected conditions. Third, integration of technology tools support the field experience by allowing students to use mobile apps. For instance, data logging, GPS and GIS tools for spatial mapping, and AR or VR application to visualize subsurface structure or inaccessible environment. All data can be shared instantly through collaborative platform for group analysis. Fourth, the combined practical workflow begins with pre-field preparation using GIS map, online research, and hypothesis development. During fieldwork, students collect and analyze data on site while working in group with the lecturer acting as facilitator rather than director. After fieldwork, students upload data to digital platform, analyze result using visual tools such as map and graph, and present their findings with peer feedback. Finally, the benefit of this approach includes stronger critical thinking and problem-solving skill, improved teamwork and communication. Also, it can enhance digital and scientific literacy and a more engaging and immersive learning experience in real field conditions.